Okay, so this problem here, I claim is going to relate to this example back here. We didn't actually talk about in class, but this one here with this curve. And the idea, so this is something you can, I'll let you guys read this at your leisure, but if you look at this parameterization of a curve, t minus sine t, comma, t plus sine t, you could rewrite that as t comma t plus sine t times that constant vector. Right? And when you make that observation, you think, well, this is an easy parametric curve. There's no problem with that. Looks like tt. That just follows straight line y equals x. And what about this? Well, here I have an oscillating magnification of that constant vector, negative 1, 1. And negative 1, 1 is easy. It just points kind of up and to the left. So as time passes, the amount that I move in the negative 1, 1 direction changes. So from this parametric curve that's moving just straight line, constant speed up at the angle, I'm moving sometimes up and to the left, and then sometimes from that down and to the right, and it just sort of oscillates then around that parametric curve to give you this parametric curve. So we're going to use a similar idea. I'll let you guys digest that example later, but we're going to do something very similar with this example. Let's see, I'm sorry, what number was it? 5. Yeah, here it is. Good. Oops, sorry, the button. Right, so here we've got position is 400 cosine t plus cosine of 12t. And then I have 400 sine t plus sine of 12t. And again, I'm going to break this up into two things. I'm going to break this up as well. On the one hand, I've got 400 times cosine t sine t plus cosine 12t sine 12t. Okay. So now the hint that I gave was, think about the moon and the sun, and so I mean, geometrically speaking, roughly, if that's the sun, the Earth. If you ask, well, what's the path of the moon around the sun? Well, it's a pretty weird path, but it's easily broken down by understanding that pretty much the Earth is going in a circle, and then the moon, in oscillating around the Earth, is just going to be doing something kind of like that. Right? And so I claim that there are a lot of numbers that we all know. Specifically, the moon goes around the Earth 12 times in a year. Number 12 is there. That's kind of a hint. And you might not know these off the top of your head, but the radius of the Earth-Sun orbit is like 93 million miles or something, and the radius of the Earth-Moon, the Moon's orbit around the Earth it's something like 230 some odd thousand miles, and those are in proportion about 400 to 1. So I claim what we've got here is we've got something that's rotating with a large radius. I claim this represents the path of the Earth, kind of. And then around that, in other words, from that parametric curve, we've got something that's rotating around twice as fast, 12 times as fast. In other words, while this makes one rotation, this is going to make 12 rotations. And so that's pretty much describing this path here. So in particular then, the way you'd construct, so the problem says, describe a simple process that would construct this curve. The process is you take that term there, which parameterizes a nice, easy circle of radius 400. And then as you're moving around there, this represents some little additional vector that's going to be rotating around that point as that point moves along. And it's going to be rotating sort of 12 times as fast. It's got radius 1. Does that make sense?
But all the way around.
And then it goes all the way around. That's right. So it's going to start off, let's say there, and it's going to kind of like that.
That's because you're adding.
That's because you're adding this more quickly rotating vector. You're going to be adding that to a larger but more slowly rotating vector, and adding up those little. It's nothing but rotations. They're just vectors that are rotating, and I'm just adding them up, and that's what generates this wacky curve. And actually, I've drawn this inaccurately. I made it look like the moon's path actually loops around, and it doesn't, because the Earth is moving around the sun faster than the moon is moving around the Earth. So it doesn't. It's really more like this. There's no loops in it, like I've drawn here. So I should have done something like that. That make sense? Did anybody ever do spirographs as a kid? So some people did, some people didn't. Okay, yeah, it's they're really cool, and you can they're little pieces of plastic with little grooved teeth on the end of it, and you can put your pencil in a little slot of one of them, and like they'll have like maybe a circle with the little teeth, and then you've got a little thing like this with little teeth going around the side. And then you stick your pencil right there, and you just kind of move it around, and the grooves make it sort of track nicely. You remember those things?
Yeah.
Yeah. So this isn't exactly that, but the point is that, again, spirographs are just kind of circles going around circles. That's all it is. And you can make pictures that look kind of like this with spirographs. It's kind of cool. Okay, let me stop this recording. I mean, they're not exactly alike, by the way, but they're similar.